post-lunch session. We are about to start post-lunch session. All the participants are requested to occupy the seat in seminar hall. त्यांना घेऊन So all the participants are requested to occupy your seat. All the participants are requested to occupy your seat. So moving to our next presentation. The next presentation will be on unit number 3, digital circuits, logic gates and digital circuits. And the resource person for unit number 3 is Dr. D.G. Bhalke sir. I will request Dr. D.G. Bhalke sir to come on the dais. Sir, please sit. So it is my duty to introduce the speaker of the session, Dr. D.G. Bhalke sir. So in brief, I will introduce Dr. D.G. Bhalke sir. So it's my pleasure to introduce our esteemed speaker, Dr. D.G. Bhalke sir, our expert for this session. Right now, he is currently working as a professor and HOD NDC, Dr. D.Y. Patil Institute of Technology, Pimpri. Dr. Bhalke received PhD in Electronics and Communication Engineering from NIT Warangal, ME in Electronics Engineering from Shivaji University, Kolhapur. His area of interest is audio signal processing, speech processing, signal processing, and machine learning. About professional society, he is a fellow member of Institute of Engineers, fellow member of IIT New Delhi, senior member of IEEE, and life member of SESI and life member of ISD New Delhi. With over of with over 25 years of experience in teaching. He has also published more than 50 plus paper in international, national journal and conference proceeding. Moreover, he has authored 2 books. Dr. Bhalke is regular reviewer of international journal. Moreover, he has filed 4 patents in his credit. Today, Dr. Bhalke sir will present on logic gates and digital circuit. So once again, I will welcome Dr. Bhalke sir. Please give a big round of applause to Dr. Bhalke sir. With this introduction, I will hand over the session to Dr. Bhalke sir. स्लाइडर आहे ना पॉइंटर आहे ना
Thank you, Professor,
Yes, sir.
for inviting me to deliver talk on unit number 3. First of all, I would like to thank the BOS Electronics authorities and the KJ College of Engineering and the management for inviting me to deliver talk on the unit number 3. Uh, all of you are teaching first year subject, that is basic electronics. I hope all of you might have taught many times this subject, and this unit number 3 is very basic. That is related to the digital electronics, that the number system, then the logic gates, and now little bit it is revised, microprocessor, microcontroller, and the IC fabrication process has been newly added to this chapter. As Mari sir has rightly said, is that even the subject is very easy, we have to create interest among the student. That is our first most job. You might be teaching for many years this basic electronic subject, but if you see the result is around 60, 70, 80%. Around 10 to 20 average number of students are fail in the first year, or even they fail in the basic electronic subject. So therefore, we have to think on that. And even all the authorities have told that now this is a year of learning. This is not year of the teaching. We have to give focus more on the learning. We have to increase learning ability of the student. We have to use different teaching methodologies. We have to use different pedagogies so that the interest will be created among student. And as far as this national education policy is concerned, we have to focus on the skill-based learning. That whatever you are teaching, that if the student perform with the help of activity, so that he will learn more. So therefore, just if we are coming and delivering the talk or the lecture, it is really difficult for the student to understand everything, and it is also very difficult to recall them during the examination. So avoid those things. So even that Jadhav sir, the trustee, has told you have to give focus on the project-based learning. On every topic, you have to design some project. You give the project on the topic so that the student will learn their own. So that is the very good way of the increasing the learning ability of the student. So, and another thing is that now the artificial intelligence has come in the market. You also have to integrate the artificial intelligence tool in your teaching learning process. Almost all students became aware about this artificial intelligence, then the data science, chat GPT, and if we are not using those tools, then we will be outdated teachers in the today's era. So therefore, you should upskill yourself. Then only you can become a good teacher, and you will get the good respect. Otherwise, all learning resources are available on the net. They are available on the YouTube. Why the students should come to the class and they should attend our lectures? So that is the big question. So therefore, student interest is declining. To increase the interest among the student, we have to change our style. We have to change our teaching pedagogies. We have to change our the teaching methodologies. You have to give focus on the project-based learning. You have to give focus on the micro project and so many things. And another, as Mari sir has said, whatever topic you are teaching, so first tell them that this topic is related to which industries, where the different job opportunities are available, so that you can attract the interest of the student. So if you can attract interest of the student and student interest is generated, definitely they will learn the very good. Even this number system is there, or very it is from the primary school is there, the same topic is there. So then also the student could not able to perform well in the examination. So that is a big question. We have to think on that. And one more my appeal, because I am having around 10-15 years of experience as HOD. So you give focus on the weak learners. That is very important. So even you teach or do not teach to the advanced learner or the average number of average students, so they are going to pass anyway. They are going to get good marks. So if you focus on those students, so definitely you are going to contribute something towards the society. Otherwise, as a teacher, we are not going to gain the respect. You will get more respect when you will give focus on the all these weak learners. So accordingly, you decide your strategy, and before going to the class, you should be well prepared. That is very important. Whenever that whatever the advanced topic or the difficult question the student will ask, or the different kind of the questions on the topic which will be asked in the gate examination, in the IES examination, so please you prepare those questions. So please try to take such kind of the question, so the difficulty level of your that the student will also be increased, and accordingly the student will gain interest and they will come to know that these are very useful. And simultaneously you go on checking the student learning ability through the different quiz or the different tests. So through that also the interest will be created. So many different ways are there. I will not go in detail. So and I know that all of you know very well about this digital electronics. Nothing to teach there. Then also I will just tell whatever I want to give information about this topic from my point of view, and how to give the different applications, different examples. Accordingly, you can give the examples and you can attract the interest of the student. Now, the unit number 3 is related to the number system. Then, in that number system, the basic number systems are the decimal, binary, then the octal, hexadecimal, then the number system conversion, logic gates are there, then binary arithmetic, then the logic circuit, half adder, full adder, then the flip flops, introduction to microprocessor and the microcontrollers, and digital IC design flow and the IC fabrication process. Okay, this is the number system. The number systems are used from the last many decades or the many years ago. And the human being is familiar with the decimal number system. All we know about the 0 to 9 or any number, if we ask, we can able to calculate its value, or we can understand what is big or the small number, etc. But when the machine will come, the machine cannot able to understand these 10 different levels, that 0 to 9. Because if you are going to use the transistor or the FET, it is going to work only in the two level, that is the on or the off level. That is called as the logic 0 and logic 1. So because of that, so this number system is being, that is the developed. So mostly in the digital or the machines are going to use the binary number system. If you want to represent very big number using binary number, so it is very difficult. So therefore, the other number system like the octal number system, hexadecimal number system are being developed. When you are going to program the computer microcontroller or the microprocessor, so you have to write the program in the assembly level language program or the high level language program. Then after that, you are converting with the help of the assembler or the interpreter to your hex codes. Then hex codes is being burned. That is the binary logic is only going to the save into the microcontroller or the microprogram. So therefore, this number system is very important as far as your the computer systems are concerned. So everywhere in every programming or the computer only understand 0 and 1. So therefore, we also should be familiar with this 0 and 1 number system. So we are going to discuss about the decimal number system, binary number system, octal number system, hexadecimal number system. One more very important thing is that very small weightage, that is credits are given for this subject. For all, only 2 hours there is a per week. So it is very difficult that how to cover and in which depth we should complete the syllabus. So my suggestion for you is that, so please try to clear the concept of the student, and accordingly you give exercise or you give quizzes on that. If you understand, explain only one number system very well, definitely the student can understand other number system very well. You can give the example and student can complete those things. Okay. So this is very basic for the number system. If anybody understand this, the this particular the number system. So what is the your positional weight of that number system, that anybody will understand that what is the value of that system. So this is for the decimal number system. So any number consists of the two parts. One is the integer, another is called as the fractional part. So for the integer part, if you consider, so there is r is there. So r is called as the radix of the base of the number system. If you go for the decimal, the base of the number system is 10. If you go for the binary, it is 2. If you go for the octal, it is 8. If you go for the hexadecimal, it is the 16. So if you explain them only this number system, we are familiar, everyone we know, automatically they will understand. And it's the positional way of this number system, that will be, if it's the first number from the fractional number right hand side, so r raised to 0. If the decimal, it will be 10 raised to 0, then the 10 raised to 1, r raised to 1, r raised to 2, and so on. And d1, d2, d0, d1, d2 indicates your the decimal digits. And similarly for the fractional number system, the positional weight will be r raised to minus 1, that 10 raised to minus 1, r raised to minus 2, r raised to minus 3, and your the digit will be like d minus 1, minus 2, minus 3. So these are your the fractional digits. So accordingly, if you want to calculate the weight of that particular decimal number system, so in the next slide we will see. So this is say the place value chart. This is important for all number system. If the student understand this place value chart, anybody can understand. So see, there is your the this is a decimal point. From this decimal point, if you go to this side, right hand side, so the place value for this will be 1, place value for this will be 10, place value for this will be the 100, place value 1000, 10,000, then your the 100,000, like the 10 raised to 0, 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4, 10 raised to 5. Here 10 raised to minus 1 immediately, 10 raised to minus 2, 10 raised to minus 3, 10 raised to minus 4, 10 raised to minus 5. So this is your the integer part and this is your the fractional part, and this is the decimal. The same, if the base is a 10, it will be the 10 raised to 0, 10 raised to 1. If it is base is 2, it is 2 raised to 0, 2 raised to 1. The base is 8, it is 8 raised to 0, and so on. The same concept is being used for all kind of the number system. We'll see this example, it is the decimal number system. If we take, it is a 356.238. So this is a decimal number. And the base of this number system is a 10. If you want to calculate the value of this any number system, so if you go, this is the first digit, that is a 6, it is a 10 raised to 0. So it is your the place value, and this is multiplied by the digit. So place value 10 raised to 1, here 10 raised to 2 multiplied by the digit. If you go for the fractional part, so this digit multiplied 10 raised to minus 1, 10 raised to minus 2, 10 raised to minus 3. So accordingly, you can able to calculate the value of any number. It may be integer or it may be fractional. Accordingly, we can calculate. So binary number system, if you look, it is same. Only the difference is that the base is 2. Everything it is same. So your place value you have to understand. So only here r will be 2. So r 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3. Then accordingly you can calculate the value of any number system. It may be binary, it may be octal, or it may be the hexadecimal number. So it is example is given. Accordingly, you can calculate the value. So this binary number can be converted to the decimal just by using this concept. So same concept is being used everywhere. So we are more familiar with the decimal, so we understand. But here only just you have to change the your place base of the system. Okay, this is the octal system. If you see everywhere it is same. Only just place it changed. So therefore, to complete this, your the number system, you might be require 1 or 2 lecture only. But you give assignment or you take the some quiz in the class so that the student will understand the concept of this. No more number of lectures are required to cover this particular number system, because this concept is also there in the third standard, 4th standard, or the 5th standard. So there is no difficulty to understand this particular concept for the student. Or you can give some activity to the student, then accordingly you like flipped classroom kind of the concept can be used, so that student will understand better all kind of the number systems. Okay, hexadecimal is also here. In the hexadecimal only different, the 16 symbols are being used, and these symbols are from the 0 to 9 and from the A to F. So there may be the base may be 13, base may be 20, base may be anything, any kind of the number system can be invented. But it is easy for us to convert octal to binary or hexadecimal to binary and vice versa. Therefore, only these number systems are being used in the market. Okay. So this is for hexadecimal number system, and this is also many students could not able to write like 0 to 16 in the binary or 0 to 16 in the hexadecimal. You try to ask them to practice this number system. If randomly if I ask anybody to write the 21 in the binary, so somebody find it difficult. So if the student make practice, so definitely they will understand. And during the conversion of the number from the one number to another, easily they can able to convert the number system one to another. So if you look here in the octal system, the symbols are only 8, that is 0 to 7 are used. After 7, again it will be 1 0 equivalent to 8 in the decimal. Like the 23 equivalent to 19 in the decimal. The same in the binary, like 2 raised to 0, 2 raised to 1 you can use. And here in the hexadecimal 0 to F, after that 1 0, then the 1 1, 1 2, 1 3 will be there. So if they remember this, then unconsciously, anytime they can able to convert the number system from the one number to the another number. It is not at all difficult. But you take only few problems and you give them some exercise, get it done in the class, they will understand. Only if you teach, if they copy as it is, they don't learn. If you give the exercise, if they do their own, so definitely they will learn better. Okay, now conversion of the number system, you can convert by decimal to binary, decimal to octal, that we will see. This is the decimal to binary number systems. Okay, directly will go. So this kind of the your number system is called the daddle the number system. In case of when you are going to convert the decimal to the binary, in case of this, we are going to divide that particular number by the number system which you want to convert. If we are going to convert to the binary, so just you the divide that particular number with the 2. Then whatever the quotient will be there, you write the quotient here and you write the remainder. Then it is the 2, if you divide the 25 by the 2, the quotient will be 12, the remainder will be 1. You go on dividing the all this quotient by the 2 till you get 0 or till you get the 1, that is the final, the remainder will be there. Here you will get 1 0 0 1 0. And when you are going to write the equivalent binary number, you go from that is a bottom to top, that is 1 1 0 0 1 1 1 0 0 1. So that is equivalent to your 25. For all other number systems, when you are going to convert the decimal to octal number system, decimal to hexa number system, the same procedure is there. Instead of 2, you divide by 8, you will get octal. Instead of 2, you divide by the 16, you will get the hexadecimal number system. So this is for your the integer part. When you are going to the convert the number to the fractional part, so in case of this fractional part, here if I want to convert the 0.35, which is in the decimal to the binary number system, instead of dividing, we are going to multiply this number by the 2. Okay. Then whatever your this the integer part will be there, or we can call it as a carry. You have to keep this carry as it is. Here it is a carry, that means integer is a 0, use 0. You write 0.70 multiplied by 2. You will get 0.40. Yeah, yeah. It is 1.4. It is 1 will be there. So accordingly go on multiplying. So each number by the 2. And you keep the carry as it is. And the equivalent, the fractional number for this is from the top to bottom. In case of your the integer number, it is bottom to top. Your fractional number from the top to bottom. So equivalent number for this 0.35 will be 0 1 0 1 1. So till you get 0, you go on continuing this procedure. Otherwise, whatever accuracy you want to achieve, you can continue up to that number system. Accordingly, the decimal number system, that is the integer and the fractional, can be converted to the binary. The same procedure will be there for your octal, same procedure will be there for the hexadecimal number system. For integer, you go on dividing by that particular number. For the fractional, you go on multiplying that number, you retain the carry, and accordingly you can convert the integer and the binary, that fractional part, to your the particular the number system. And this already you know the concept. When you are going to convert directly by these positional weights, directly also you can convert, or you can convert by that number system. When you are going to convert binary to the decimal, so these are called as your the positional weights. So if you go for this is an integer and here it is a fractional. For the integer, the first digit, the positional value is 2 raised to 0. Positional value is 2 raised to 1, 2 raised to 2, 2 raised to 3, and 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4. The same for the octal, same for the your hexadecimal number system will be there. Then accordingly, when you are going to convert any number, so just you multiply this particular digit by the positional value. Automatically it will be converted to your decimal, or any hexadecimal can be converted to decimal, octal can be converted to your decimal. And just you add all values, so you will get equivalent the decimal number. So in case of this, if it is like the 1 to the 4a, it's a first 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8. So when you want to convert any number, then accordingly, suppose it is 10110 is there. So this is your the first 2 raised to 0 weight. Here 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4. These are the positional values. Multiply positional values by this binary digit. So whatever value you will get, that will be your equivalent, the decimal. The same thing will be there for fractional. So here you can add, if it is 2 raised to minus, it is a 0.5 multiplied by that digit, 0.25. You add these values, you will get the fractional value. And this concept is there for same when going to convert the any binary to decimal, octal to decimal, hexadecimal to decimal. The same the procedure can be used for this. This is decimal to octal. The same concept is there. I'm not going to go in the detail about this number system. All of you know. Okay. Here this is same how to write from the 0 to F in the binary number system. Okay. Then hexadecimal to binary number system. So hexadecimal to binary is, you know, all of you that every the hexadecimal number is represented by the 4 binary digits. So accordingly, equivalent we know from 0 to F. So what is the equivalent binary number? So if it is 2, the equivalent binary is 0010. Like if it is C, then it will be 1100. If you know, then immediately you can recall, and accordingly you can write the binary number. So 16 can be converted to without doing any calculation. Okay. Then in case of the octal number system, also the procedure is same. Okay. So accordingly you can do. So in the number system or the conversion of the number system, it is not at all difficult. Only one concept, if you explain to students, the same they can perform. Then binary addition concept is also there. In case of this binary addition, there is a the addend and the minuend will be there. So these two can be added. You know the concept 0 plus 0 is 0. Then carry will be 0. And 1 plus 1 sum will be 0 and the carry will be 1. Okay. Basically, this binary addition system are used in all the your microprocessor and the microcontrollers. In the CPU, there is your the arithmetic logic unit. So accordingly, you can give the example and the student can design the like the ALU where or the adder or the subtractor where they can use the concept of this binary addition. Then binary subtraction is also there. Okay. And I think one's complement is there in syllabus or not is not written. Only they have written binary addition, but I don't know in the exam it is there or not. But you can also explain the ones complement. You know, when you are going to convert 0 to 1, 1 to 0, that is called as your ones complement. And when you are going to perform the addition of the subtraction, so you can perform convert that your the negative number to the positive number by ones complement, and you can perform the subtraction by addition because there is no the subtraction will be performed in the arithmetic logic unit. So you can go this. I will not cover this. Okay, next I will go. Then these are some of the examples you can give after completion of that particular concept. You give example and you check verify the answers from the student so that they will do it. Okay. The next part is about your the logic gates. Basic logic gates, symbol, truth table, Boolean algebra rules are there. Then these are the basic gates, universal logic gate and the De Morgan's theorem. You can give examples to the student where the basic logic gates can be used. In our day-to-day life, we are using the basic logic gates because the based on the inputs to basic logic gate, the output will be generated. If suppose I create the truth table that if suppose in the agriculture I am going to use three sensors, one may be the moisture will be there, another will be temperature, another will be humidity. So based on the value of that particular the parameter, so the output of that sensor will be there. So it will create your either high or the low voltage. And if you go to the particular the gate and based on your logic, if suppose you want to on the motor or off the motor, so in that case this simple example can be used. Or even suppose you want to in this room automatic temperature control you want to design, so this can be designed very using very simple logic gates. So just you sense the temperature sensor, output of that will be there, or your the motion sensor will be there, whether there is some motion is detected in the class, or there is a human detection sensors are also there. It is there or not, that also you can take, and output of this sensor can be given to the logic gates. So based on the parameter, the your fan will be on or the off, your the tube lights will be on or off, your AC can be made automatically on or off. So these kind of the application can be developed using very simple logic gates. So that is the application of the logic gates. Accordingly, you can also demonstrate to the student. You can come along with the breadboard and you take some sensors and you see the whatever values are there and how the output you can connect one relay and output bulb and you can check that how the bulb will be on and off so that the student will understand. Even the concept of these logic gates can be taught by using different simulation tools. The Tinkercad is also very good simulation tool is there. All sensors are available. You can demonstrate how the your OR gate can be used, AND gate can be used, or the XOR gate can be used, or the universal logic gates can be used. So if you demonstrate or if you can give some micro project to the student, that would give some application. In the chat GPT, just if you write, create like your the 10 different problems based on the your logic gates. So all problem will be created. You can give group wise assignment that student can create and they can verify in the laboratories and they can understand the concept better. So such kind of application if you tell student, so it will become interesting and it is a fun for them and it will be kind of the small micro project and they will understand the concept very well. Okay. So moving ahead with this, okay. So basic logic gates are the NOT gate, AND gate, and OR gates are there. Okay. The NOT gate, you know that it is an inverter. So if you give zero, output will be one. If you give one, the output will be zero. And accordingly, its truth table, you can tell them about the AND logic gate. Okay. So this is the AND logic gate. So you tell them that if unless until all the that ask them to explain the AND gate only in the one sentence. If all the input to the logic gates are one, the output will be one. It may be three input gate, it may be four input gate, it may be five input gate. That also you tell them. And this you come along with some ICs. You tell them this is the IC for the AND gate, and inside this IC there are the four the AND gates are available. God, that is a gate is there. Then like three input AND gate, four input AND gate, and you can show the data sheet to the student that what will be the different parameter will be there, how they can be used. Accordingly, they can understand. Okay, this is OR gate will be there. Okay, this is the truth table for the OR gate. If one of the input to the OR gate is one, the output is one. So this is it may be three input, it may be four input, or the five input will be there. So this is just the symbol for the AND gate, OR gate, NOT gate, and the truth tables are there. Okay. Then the combination of the and the NOT gate. And just whatever the AND gate output is there, to connect to the NOT gate, it will be inverted. So that will become your NOT gate, and that bubble will be added to that. So this is the NOR gate, this is NAND gate. So like NAND and the OR gate is there. Then the XOR gate is there. In case of the XOR, so how will you define the XOR gate in one sentence? Same input, output is zero. But if it is three input, yeah, right. If odd number of inputs are one, the output of your XOR gate will be one. So sometimes in the exam they will ask for the 3 input XOR gate. The student will be confused. So like these kind of things you can teach to the student. Okay. So you see. So this is your the 3 input XOR gate. So what is the output if all the inputs are 0? Output will be your low. If odd number of inputs are 1, then only the output will be high. Here only one input is high, so output is high. So here all the input are high, odd number of inputs are there is a 1, so output will be your low. XOR output is high only when odd number of input is high, but here I think this is wrong. Yeah, this is wrong. So this is the truth table for the 3 input XOR gate. You ask student to prepare the truth table for the 3 input, 4 input, or the 5 input, so that they can understand. And you also tell there are so many applications of XOR gates are there, which are used in the communication. So like you can tell the example, basically they are used in the error correcting codes. XOR gates are used. So you can tell. This is the XOR gate. XOR instead of 1, odd number of the input are low, then the output will be 1. So or the whatever XOR input is there, it's our inverter. It will work as inverter of the XOR gate. Okay. So XOR output is high only when the odd number of inputs are low. So like for OR gates, you try to define only in one sentence and you give them some micro project for every group of the 4 to 5 student to design some application like the automatic temperature controller of the room or the agriculture applications or the traffic light controller by using simple logic gates. So definitely they can design, they can use the simulation software and they can also use the hardware and design and they will demonstrate. Their skill will be developed in that and automatically many creative idea will come where they can use to design the projects. Then next is a Boolean laws. There are some few important laws are there. There is a commutative laws. There is a plus b is equal to b plus a or the ab is equal to ba that you can demonstrate with the help of the truth table. Okay, they can see here the example is given with the help of bulb. If you connect a and b bulb okay, in the parallel, here your bulb will be on. Instead of that, b and a are connected. The same thing will be there. Associative law that you know a plus b plus c is equal to a plus b plus c. Okay, you demonstrate. Distributive law is there. Okay. These are the basic Boolean laws. And another important thing in this chapter are the De Morgan's theorem. So when you want to convert the soft form to the POS or POS to soft form, in that case the Boolean laws are used. There is a b bar is equal to a bar plus b bar. You explain with them the truth table so that they can remember. So basically they are used for implementing NAND logic or they are used to implement using the NOR logic. When you want to convert NAND to NOR or the NOR to NAND, you can use the De Morgan's law or during the simplification of Boolean law algebra. So you can use these things. Here truth table is there. So accordingly you can prove that De Morgan's laws. Okay. So these are some the other laws are there. Okay. Another important thing is the universal logic gates. So all of you know universal logic gate. NAND and NOR are called as the universal because any logic circuit can be implemented using only one type of NOR gate or only one type of NAND gate. So therefore they are called as universal. When you are designing the circuit may require AND gate, NOT gate, OR gate, or the other kind of the gates. But for that, the hardware required will be more. You require different ICs. So total hardware will be more. The cost of the system will be more. It will become complex. The propagation delay will be more. So to avoid that, only one type of logic gates are used. So therefore, generally universal logic gates are used to design the circuit because it will give the simple circuit. The cost of the system will be low. The propagation delay of the circuit will be less. So therefore, generally, this NAND and the NOR are used for designing any kind of circuit. You can design, you can give the how to design the NOT gate using NAND gate, how to design the NOT gate using the NOR gate, how to design AND gate using NAND gate. So you can give the example. Here the example of the designing the NOT gate using the NAND gate. So both the inputs are connected together. So it will work as an inverter.
You can design NOT gate using NAND. You can design here. This is also another example. If you connect one of the input to the logic 1, and whatever input will give, it will be inverted output will be there. So in both ways, both can be connected together, or one of the input can be given as a plus 5 volt, and another input you can give the input, the output will be inverter of this, because you know the truth table of this logic, and accordingly you can explain. But for the case of your the NOR gate, one of the input is connected to the ground. You want to make it the NAND gate. Here it is connected to the plus volt. When you are going to convert this NAND and the NOR gate to the OR and the AND, so this concept can be used, or this concept can be used. So this is your the AND gate using the NAND and the NOR gate. So AND gate output will be A into B will be there. If you go A into B, so the output of this will be your the AB bar. So when you want to get it is A plus B, you have to give to the NOT gate. It is a complement of it. So accordingly, this NOT gate means one of the input is connected to the plus 5 volt. By applying the De Morgan's law, so you will get this kind of the gate. So these are the example. These are the very popular example of the AND gate using the NAND and NOR gate, or the OR gate using the NAND and NOR gates are there. Okay. And its truth tables are there. So these are some of the questions. Define universal logic gates. Why they are known as the universal logic gates? State and prove De Morgan's theorem. With the help of truth table, explain operation of like this. So what generally I do in the class after completion of the unit, I give such kind of the question to each group of student. I ask them to prepare on the chart papers, poster, and they have to come on the stage and they have to explain. So their communication skill, their all other skills will be improved, and they will also learn better. So such kind of exercise can also be taken in the class, so that your teaching learning will become more interesting. Okay. Now this is your the half adder will be there. Then full adder, flip flops, JK flip flop, T and D flip flop. Concept of microprocessor and microcontroller will be there. So in case of half adder, only one bit addition will be there. So addend and subtract, addition and the carry. So that already you know. When you want to implement this using the logic gates, you see 0, 1, 1, 0. It is the output of which gate? It is the XOR gate. When it is 0, 0, 0, 1, it is output of 0, 0, 1. When the both the input are 1, the output is 1. It is AND gate. So this half adder can be implemented by using your XOR gate and AND gate. So accordingly, this is a XOR B, and your AB will be there. So you can show this like designing the circuit. This is your the half adder circuit. Generally here K-map is not taught to them, so they cannot able to design the Boolean expression for the sum and the carry. But using logic gates with the help of truth table, you can explain that. Similarly, the disadvantage of this is that if the carry is generated from this end, so that carry cannot be added to the half adder. So therefore, the concept of full adder is there. So in the full adder, if you go, so this is the truth table for the full adder, where the A, B inputs are there, the carry input is also considered. And accordingly, the sum and the carry will be there, where you know the addition 0 plus 0 and the carry is generated. And ask the student to design this truth table with the help of the logic gates, so that they will understand which logic gates can be used for that, because the K-map is not there. Then accordingly, if you see the sum will be A XOR B XOR C. That is the XOR gate truth table, 3 input XOR gate truth table. So if they know the 3 input XOR truth table, they can easily understand the sum can be generated by using A XOR B XOR C. And here in case of this carry output, here the OR of AB, A and C and the B and C, that carry will be there. Then accordingly, so this is a logic diagram for the full adder circuit. So this asks them to design in the multisim or the Tinkercad, ask them to give the input and verify the truth table in the class or during the practical, or they can understand the concept of half adder and the full adder. And generally all these half adder, full adder are used in the microprocessor or microcontrollers. Even subtractions are also performed using your adders only. So just if they understand, so they will understand the application of this half and the full adder. And the another concept of the flip flop. So generally flip flop are used as a memory. So they are considered as a 1-bit memory. So these logic gates do not have the memory, but it is having the memory. So they are used to design any big memory. All consist of your the flip flops, and they work on your the clock pulses. Generally, the clock pulses will go low and the high. The output of the flip flop will change during the leading edge. or it will change during the trailing edge or during the level. So that is called as the edge triggered flip flop or the level triggered flip flop. Edge triggered, high edge triggered, low edge triggered, or the level triggered. That is high level or the low level triggered. So during that transition, so when it is going 0 to 1, so output will change, or when it is going from 1 to 0, that time it is changed. It is called as the edge triggered flip flop or trailing edge, leading edge triggered, or the high level end or the low level end triggered flip flop will be there. You can explain them the concept of edge triggered kind of the flip flops. So generally this flip flop will have the two inputs, and the clock pulse will be there. After applying the clock pulse during the high or the low or during the level, the output of the flip flop will be changed. So this is a truth table of the flip flop. Okay, and here it is a simplified the truth table of this flip flop will be there. When both are 0, the output will be, that is a complement of the present state. That is a QN bar will be there. Okay, when 0 1, it is called as the reset. The output, that is a QN plus 1 means the output after applying the clock pulse. So it will be 0. It is called as the reset. Then when it is 1, it is a 1. It is called as a set. And when it is 1 1, the output is not the predictable. So that is called as the race around condition. So to avoid race around condition, don't teach them in detail about the race around condition. That is the problem. So there is another flip flop is there, that is called as the JK flip flop. So this is the truth table of the JK. Only there is a change in this truth table. So we explain the symbol, age triggered, level triggered, the truth table. So that is enough for the student here. Then JK flip flop can be converted to the D flip flop. D is called as delay flip flop. Whatever input is there, the output, same output will be taken from that flip flop. It is called as the D kind of the flip flop. It can be converted by using the NOT gate. So that input is converted. Then this is the T flip flop. When both input are connected together, that will become your T flip flop. Then applications. So there are a lot of applications are there during the counter designing or the memory designing. So these flip flops are used. Then another important last point is about the microprocessor and the microcontrollers. So most of the student or even we also confuse because of the microprocessor and the microcontroller. What is a microprocessor? Microprocessor is a central processing unit on a single chip. Central processing unit on a chip is called as the microprocessor. What is microcontroller? When the CPU input output devices and the memory devices are fabricated on the single chip, that is called as the microcontroller. So tell them example. And another important difference between microprocessor and microcontroller is microprocessor is a general purpose device. You can use it for any application. You can give example of the laptop or the computer. So if we do the different program, it can be used for different application. But microcontroller, once if it is designed and the program is stored into that, throughout its life it is used for only that application. Like the traffic light control will be there, or the mouse will be there, or the keypad will be there, or in the automobile industry. So a lot of devices are there, whatever embedded devices, they use microcontroller, and throughout its life they are used to perform only one task, that is a microcontroller. And microprocessor can be used for any purpose. So only they have written block diagram of the microprocessor and the microcontroller. Okay. So this is a block diagram of the microprocessor, which consists of arithmetic logic unit, different registers will be there, and the control unit will be there. So this is just CPU on a chip. Okay. So if you tell them about this is your block diagram of the computer. The computer means our CPU is there. In the CPU there are also input output devices are there. So that is not the microprocessor. Microprocessor is only the single chip, which consists of ALU, registers, and the control unit. And these are input output devices which are connected externally. Then accordingly, the computer can be designed. Just to explain them about this concept of the microprocessor, that is a CPU on a chip. And different the history of microcontroller, 4-bit, 8-bit, word length. You can give example where they used. And today's that is your Pentium 1, Pentium 2, Pentium 3. So just you can tell them comparison for their knowledge. And about microcontroller, CPU plus input output devices, the RAM, ROM, timer, serial COM, all peripheral devices are fabricated on single chip of the semiconductor material. That is called as the microcontroller. That's the difference. Only block diagram is that you can tell them the example of the microcontroller like 8051 PIC microcontroller. Other lot of microcontrollers are available. You can tell the comparison where they use their applications. So that is only that concept is covered here. Okay. This is also same block diagram of the microcontroller. This is the difference. First difference is general purpose, special purpose. Only CPU on a chip, CPU, input output device, memory are on the chip, and you can give some applications. So that same difference is that it is elaborated in detail. This is also difference. Okay. Then applications. Then these are some questions. Explain in detail the working of the full adder with the help of the truth table. Explain different type of flip flops and state one application. Draw block diagram of microcontroller and explain its function of each block. Draw block diagram of the microcontroller. Explain the function of each block. There will not be more kind of the questions. Such kind of questions will be asked. So last point is that just it is because now our government has taken the semiconductor mission. Now the 3 fabrication labs have been started in India. So in future, next 5 to 10 years, more number of fabrication lab will be there. There are a lot of the opportunities will be there for the semiconductor technology, and mostly they will be available for our ENTC engineers. You can tell them about first why the semiconductor, the IC fabrication is required, and what is IC integrated the technology. How many ICs like MSI, LSI, VLSI. So just you can tell them the definition, and only the fabrication process is there. So I don't know in detail about the VLSI, just I have taken it from some resource like routing, physical verification, static timing analysis, then the power analysis, signal integrity analysis, fabrication and the testing. And after testing, they will give to the fabrication lab for the chip manufacturing. And after manufacturing, they will test that particular chip. Once if it is verified, and in the mass, they can the fabricate the number of ICs. So this process is followed during the IC fabrication, and it is only just they should know the process. You give example of the IC fabrication lab where in India or the abroad the ICs are fabricated. Okay, and this is IC fabrication process flow. Is there? Okay. Here it is explained in detail all the steps about the IC fabrication process steps. Only these 2 points are there. You explain them with the help of examples. Okay. So that or there are many YouTube videos are there, and even you can show them the YouTube videos. The concept will be clear. Okay, this is about the end of unit 2 because 30 minutes was given to me. So just I have touched up because all of you know about this. It is not you are teaching all the concept to you people, but you give more example to the student and you get it done from them so that they will learn better. That is only my suggestion. And as Mari sir suggested rightly, you give different example of the different industry, embedded industry, IC fabrication industry, or the different application of your the logic gates, or the number system. The student will understand better. And accordingly, after completion of that, you need to give topic to every group, ask them to prepare on the poster and to demonstrate on the stage. They will understand better. Thank you all. If you have any question or doubts, you can ask. No?
Thank you, sir, for a nice presentation.
Actually, I have not got any time first year subject, but
It is my privilege to extend our. It is my privilege to extend our sincere thanks to Dr. Bhalke sir for his insightful session today on logic gates and digital circuit. So, in a very short span, he has covered more than 100 PPT. He start from logic gates and end up with the IC fabrication, and also he has covered the microprocessor and microcontroller part also. So, let us give a big round of applause because in short version he has written a lot of things in a nice manner.
we'll give PPT to organize.
Yes,
and take from them.
Dr. Bhalke sir has provided us with comprehensive understanding of topic logic gates and digital circuits. We deeply appreciate the time and effort you invested in preparing and delivering this session. Your expertise in logic gates and digital circuit has greatly enriched our knowledge. Once again, thank you, Dr. Bhalke, for your valuable contribution. We look forward to applying the insight you have shared and hope to have the pleasure of working with you again in the coming future. So once again, thank you, sir.
Thank you all.
Thank you. Now I request Professor Sheikh to introduce the next speaker, Professor Dr. Hambade, sir.
Good afternoon, everyone. Myself, Professor M. Sheikh. I take this opportunity to introduce today's research person, Dr. Shailesh Hambade, sir. Our expert for this session, Dr. Shailesh Hambade, sir, HOD ENTC, JSPM, JSU Adak, sir, Pune. Dr. Hambade, sir, received PhD in Electronics Engineering from Rashtrasan Tukadoji Maharaj, Nagpur University. He completed his Master of Engineering in Electronics from Shivaji University, Kolhapur. About professional societies, he is a member of LMIST with over 20 plus years of experience in teaching. He has also published more than 20 plus papers in international or national journals. He is a regular reviewer of IEEE International Conference. Moreover, he has granted 2 patents in his credit. Dr. Hambade sir and team JSU Hadak sir is recipient of award in Ayush Bioinstrumentation, All India Institute of Ayurveda. They received first prize in category by Honorable Shri Narendra Modi, Prime Minister of India. Today, Dr. Hambade sir will be presenting on operational amplifiers and electronics instruments. Please join sir, giving a warm welcome to Dr. Hambade sir. With this brief introduction, I would like to request Dr. Hambade sir, please proceed for the presentation.
Thank you, sir. Thank you to Savitribai Phule University and KJ Group of Institutes to give the opportunity to deliver the lecture on this orientation program. I know it is very difficult to attend the fourth lecture as a teacher and after the one good induction program because we all are the teacher, and so I'll just give the some basic information to maintain the uniformity in the syllabus throughout the university. Okay, so in this fourth unit, if we are considering the fourth unit, okay, syllabus of the fourth unit is categorized in the two parts. First one related with the operational amplifier and second one is related with the instrumentation amplifier. So operational amplifier when we have considered, because basically when we discuss in the class and that time there is the amplifier. So students, first you need to give the example of the amplifier because we know there is the audio amplifier is available in our seminar also. So what is the amplifier basically? And after that you need to discuss about the operational amplifier. Okay. So for this unit number 4, if we are considering the CO is the understand the functional of op-amp and electronics instrument. So this is the CO is related with the understand, and we know the in a Bloom's taxonomy if we consider on the basis of the NBA. So it is nothing but the second level. So first is the remember, second is the understand, and third is the analysis, apply, then evaluator and create. But this is the understand level, and that means we need to consider this unit in the understand base. So in this unit there are the two categories, and in this category if we map with the different type of the PO, so that time our unit is definitely map with the PO number, that is the knowledge. Partially we have considered as the point of view as the analysis because there is the some numerical on the op-amp, and also we have considering as the modern instrument or modern tools, PO number 5, because PO number 5 there are the different type of the DSO we have considered in this unit, and this is the
This is the part of the modern tools. So partially we also map with the PO number 5 this unit. Now, when we have discussed about the op-amp, so first you need to explain about the amplifier, because student from the unit number 2, we use the transistorized circuit and there is the transistorized amplifier. So we need to provide the information related with the operational amplifier, because when we ask the any student in the second year level also, that time they give the answer related with the amplifier only, but if we ask the question related with the operational amplifier. So first we need to discuss about the, there are the different type of the operation performed by the op-amp, and after that there is the application. So in this way, suppose there is the question, so you need to create the interest in the students. So like that, just ask, use as a Kahoot, use as the Slido, or you use the flip type of the class flip type of the tools in the class to create the initiative and ask the such type of the question and create the poll. If we create the poll, student automatically take the interest in that different question and definitely try to give the better answer. Now block diagram. So this is the, because you are already, most of the faculty member already taught this subject 4 or 5 times maybe. But when we have discussed about the operational amplifier and its block diagram, in a syllabus structure only given the block diagram related information, but we need to provide the in detailed information of the each block, function of the each block, then circuit, which circuit used in the each block, and importance of that circuit, because we know there are the 4 blocks and each block have their own role. In the first stage we have considered the very high input impedance. Second stage we have considered provide the additional input impedance and additional gain. Then level shifting stage and as well as the output stage. So there are the different circuit with within the different block, and you need to give the information of the each block with its circuit diagram. With circuit those we use in the each block and importance of that block. Okay, this is the one is the additional things I am just add here, but it is not for the students. Suppose if you share this slide with the students and if you are given the information related with the how this block are working in the op-amp, so that time there is the input stage, then intermediate stage, level translator and output stage. So there is the dual input balanced output differential amplifier we have used as a first stage, then dual input unbalanced output circuit used as an intermediate stage. Then different type of the level shifter we use, because we are not used as a capacitor as the coupler. Here we use as a different type of the level translator, and then output stage and our importance of the output stage, how to provide the high current to the output circuit and how to provide the low resistance to the output circuit. You need to give the information related to that. Now this is the basic information related with the op-amp again. Now symbol. And one, if you are observing the symbol, you need to give the detail about the symbol as well as the IC structure. With the there is the 8-pin IC, and you show the different type of the op-amp ICs if available in the lab. Just carry this IC in your classroom also and show this IC to the students and their pin configuration, because students is in first year and they are more interested in this type of the ICs and such type of the components. So just try to show the different type of the components those we have studied in the first year in the throughout the your lecture and create the interest in the your lecture. Now next point in this unit is related with the different type of the parameter, different type of the characteristics of the op-amp. So there are the different parameters, and we need to give the information and importance of the each and every parameters. It may be the related with the high input impedance, then low output impedance, then common mode rejection ratio. It may be related with the open loop gain, and then gain bandwidth to the product, then slew rate. So you need to give the definition as well as its ideal value and its practical value, because if you observe your question structure, question paper structure also, so that time definitely there is the question related with the different type of the parameter of the op-amp. So define the any one or any two parameters of the op-amp, then write down its practical values and ideal values. So students should know the difference between the what is the ideal value and what is the ideal value and practical value. So why we have considered the ideal and why we are considering the practical. Practical is the data set is available in the different type of the op-amp ICs data set, and it may be that we have mostly used the IC number 741 in the practical also, and those practical we have performed in this unit. So we have considered as the from the using the IC 741. Now there are the different application of the op-amp. In the syllabus structure, there are the only two applications are mentioned. One is nothing but the inverting amplifier. Second one is nothing but the non-inverting amplifier. But before start this inverting amplifier and non-inverting amplifier, you need to clear the concept of the virtual ground concept. If you are not clear this concept to the students, so that time it is very difficult to understand the inverting amplifier and non-inverting amplifier. Because if we are considering the any analysis or derivation related with the inverting or non-inverting amplifier, first student should know the virtual ground concept. So before start this topic, you need to complete the virtual ground concept. Why there is the same voltage is available at the inverting and non-inverting terminal of the op-amp. Now this is the inverting amplifier. So inverting amplifier, we need to provide the circuit diagram, and when we are considering the circuit diagram, try to show the derivation for the inverting or it may be the non-inverting in a one way. So you try to show the direction of the current, and if you are showing direction of the current and accordingly if you write the equation for that each and every current, so that time students will easily understand so how to find out the equation for the output voltage. So I have just given the example of the inverting amplifier with its derivation, and output voltage for this is the RF upon R1 into P. So minus sign is indicating that there is the 180-degree phase shift. So but student, you need to provide the information related to that. So what is the 180-degree phase shift? And this concept only it is possible when you are considering this practical within your simulation phase or through the your DSO or CRO. So definitely, because most time we have observed that you have shown the one single waveform on the DSO or it may be on the CRO, but try to show the both input as well as the output waveform on the CRO or DSO, so student get the detailed information related to so what is the exactly 180-degree phase shift in the input and output. Then again we have considering the try to give the different type of the breadboard to the students and op-amp ICs and components, and try to perform the one practical function through the function generator, apply the signal. So that means just give the information to the students only related to how to there is the connection in the breadboard, and provide the components and ask them to just show me the output for this input signal. Suppose I am applying that 5 millivolt, 20 millivolt input signal. So how there is the output signal is available, how to calculate the signal, because there is the so many simulation software is available in our lab. So it is easily possible in the hardware breadboard also, or it is maybe the by the simulation software also. Then this is the one of the inverting amplifiers. Here I am just trying to show that there is the 180-degree phase shift between the input and output and direction of the current. So this is the information related to the inverting amplifier. Then there is the non-inverting amplifier. So again there is the derivation only related. We have just considered the derivation related with the only for the gain of the inverting amplifier and non-inverting amplifier. We are not considering the other type of the derivation. It may be the input resistance, output resistance, like that. Only is as a part of the syllabus. We need to take over the only related with the how to calculate the gain of the inverting amplifier and non-inverting amplifier. So there is the V0 1 plus R1 upon Rf into V is the gain for the non-inverting amplifier, and this circuit also one we use as a unity gain amplifier. Unity gain amplifier is not a part of the syllabus, but you need to give the information related with the unity gain amplifier and importance of that. Again, you need to provide the information where we use this op-amp circuit as an amplifier with example of the some industry example. Now I have just given the some YouTube links. Those one given the information related with the detailed information related with the inverting amplifier, non-inverting amplifier, as well as the op-amp. Now these are the reference point for this. I have given the details related with the op-amp parameter as well as the voltage series, but this is only for you, not for the students, because in the syllabus point of view only there is the block diagram of the op-amp, then parameters of the op-amp, inverting amplifier and non-inverting amplifier. Only these points covered in the your syllabus. Now second part of this unit is related with the instrument, because we know I have already told you that there is the we have considering the PO number 5, that is the modern tools, and if we map this PO with our CO of this unit number 4, so that time we use the advanced instrument in this as a part of our laboratory, as a part of our syllabus, or as a part of the lab. Now, there are the total 4 instruments covered in this unit number 4. First one is related with the digital multimeter, then function generator, then digital storage oscilloscope, and last one is nothing but the power supply. So when we are providing the any information related with the any type of the instrument, so that time you try to show the different type of the samples available in the market, because we know that there are the single type of the function generator is available in the lab, and there is the specific limited functions are available on that front panel of the function generator, or any type of the GSO we have considered, or any type of the multimeter. So you try to give the information to the students, just show the sample images of the different type of the multimeters available in the market, different type of the functions available in the digital market, because we know there are the up to the 5 digit, 6 digit, and 7 digit multimeter, true RMS meter are also available in terms of the digital format. So we need to provide the information. This instruments is not available in our lab, but we need to show this sample basis or image basis to the student to create this type of the instrument is also available in the market. So this is the digital multimeter, and first try to discuss with the students what is the digital meter and what is the role of the digital meter, and how to measure the values. It may be the current, it may be the voltage, it may be the resistance, or how to test the diode by using the multimeter, how to test the transistor by using the multimeter, how to measure the HAP of the transistor by using the multimeter, because there are the many functions available in the multimeter, many functions available in the front panel of the CRO, many functions available in the GSO, but we used to limited function out of that, and only we have focus on that only. Channel 1, channel 2, then amplitude and frequency. We have not discussed about the there is the trigger point is available, then reference point is available, then external trigger point is available. So we never discuss about that, but try to present each and every knob present available on that front panel, because if you discuss, so that time it may be the possible to create the interest inside of the students, and they may be the try to search some information related with the advanced instrument available in the market. So these things are related with the digital multimeter. Now block diagram of the digital multimeter, because there are the 4, and always there is the one question if we are considering the exam point of view, so that time there is the always there is the one block diagram out of 4 maybe the in an exam paper, but forget about that. But students should know so how to work, because this diagram, those block diagram we have considered in a as a multimeter, as a DSO, or as a function generator. These are the basic thing. Same diagram is not available inside of that multimeter, because there is the so many features, there are the so many applications are there, and accordingly there is the circuit diagram is available. But we have considering the basic, because we know there are the buffer amplifier required the calibrator for the AC signal, then convert the voltage into the current to voltage converter, current to voltage converter, then calibrator meter for the different type of the current being measured. It may be the DC value, it may be the current value, it may be the resistance value. So accordingly, we need to rotate the knob. Suppose we have considering the digital display, give the information related with the digital display, because suppose same type of the multimeter available in the lab. So just give the information related with the there is the different type of the multimeter are also available in the market. Some digital multimeter have the 4 digits, some have the 3 digits. So you need to give the information about that, and you need to give the application of that multimeter also. Then these are the some functions in a how to keep the knob position, because first year students should know how to keep the position of the knob, when there is the milliampere, when there should be the ampere, when there should be the kilo ohm, when there should be the mega ohm, and when we need to rotate the knob. So just try to give the information related to that, and how to select the range for the, it may be the for the voltage, it may be the for the current, or it may be for the any parameter those we want to measure by using the multimeter. Now out of this is the front panel for this digital multimeter. Now these are the values are mostly available on the front panel of the digital multimeter, and with their symbol for the AC symbol, for the DC symbol, then for the kilo ohm, mega ohm, then for the diode test. Because multimeter to multimeter there is the variation. It may be the possible we have discussed in the classroom one type of the structure in the classroom, and when student enter in the lab, so that time observe there is the different type of the multimeter available in the lab. So because of that, to that time it may be that there is the little bit confusion inside of the student. So avoid that. So you need to provide the what is the difference, what type of the study we have considered as the theoretical point of view, and what type of the practical by using the exactly in the lab how to handle the multimeter for this parameter. Okay, so try to avoid the confusion of the students. Now these are the ports. So when we consider the milliampere, when we are considering because in market there is the up to the 20 ampere multimeter is available. So when we need to select the 20 millimeter, when we need to put the probe in the volt ampere or diode. So accordingly you need to give the information inside of your lecture. Now same thing is there. These are the different then including the conductivity testing point is also available in the multimeter. So you need to give the information of that point also. Now this is the I have in this presentation I have provided the different type of the YouTube video lectures or YouTube videos so related with the digital multimeter, related with the DSO. For the each topic those are available as a part of the unit number 4. Now function generator, same thing. Function generator, many times when we ask the students in the second year level also, what is the function generator? Function generator is the input device or output device. Many students just give the answer like that. Function generator is nothing but the output device or output instrument. So this is the confusion in the students. Okay. So to avoid that, you need to first provide the information related with the function generator, how it generates the signals by using the proper block diagram of the function generator, different type of the signal generated by using the function generator, because there is the mostly in a basic as a block diagram point of view we have just considered only basic point of view. We have considered only triangular wave, we have considered the square wave, and we have considered the sinusoidal wave. But actually when we have considered it as a function generator in the lab or different type of the function generator available in the market, so there are the multiple functions are available in the function generator also. So that time also you need to give the information. You again I will repeat these things. So you need to show the in your lecture the different type of the front panel of the function generator available in the market, and what is the role of the knob of the front panel available in that function generator. Okay, so same thing for the DSO also, and same thing for the power supply. This is the basic block diagram for the function generator. In this, if you are observing, there are again only 3 waves: output waveform, triangular waveform, sinusoidal waveform. So how to convert this waveform? What is the role of the integrator? Because student already studied about the op-amp, so they know the role of the op-amp, and then we use the one capacitor as a feedback path. So that time how to there is the integration, and how to convert our square wave signal into the triangular wave signal, and how to convert this triangular signal by using the diode shaping circuit into the sinusoidal. So you need to provide the information related to the each and every block to the students, because if I am just draw the block diagram and just show the waveform, so that time student not get the information related to, so why these signals are here from this only the input signal. So you need to provide the information related with the each and every blocks available in the function generator. Now this one is the front panel for the one of the function generator. So there again there is the one part as a function generator. When we are considering, there is the one point is related with the offset setting. There is the one point related with the duty cycle. Then there is the offset and duty cycle, because mostly we focus on the frequency and only focus on the amplitude, and one again we focus on the type of the waveform. Only we focus on these 3 points: one amplitude, frequency, and type of the waveform. But you need to provide the information to the students related with the what is the offset, what is the role of the offset. Those point is available on the front panel of the function generator. Then you need to also give the information related with the duty cycle, how to change the duty cycle, what is the importance of the duty cycle. So by using this in this function generator. Now this is the detailed information related with the frequency, types of the waveform, then function offset and duty cycle. This is the link available for the function generator. Now, digital storage oscilloscope. In the digital storage oscilloscope, because we know CRO is the one of the display measurement instrument we have considered, but we replace in the syllabus CRO by using the DSO. So first you need to provide the basic information related with the CRO, and now how to replace this CRO by using the DSO, and what is the additional features available in the DSO, because we know there are the storage capacity, save and hold capacity is a function. These are the additional functions. We can add the two input signal by using the DSO. We can subtract the two input signal by using the DSO. These many things are available in the DSO, but you need to give the information of this to the students, not only about the DSO and front panel block diagram of the DSO like that. So you need to provide the information of the DSO in details. So how it works and what is the additional features of the DSO in compare with the CRO, because they don't know about the CRO. It may be the in the 12th they only observe the CRO in the lab. They little bit information maybe they have, but we know the give the information related with the CRO and how we have replaced the CRO by using the DSO, and what are the more beneficial this DSO in term of the application. Then digital storage application, basic working principle of this and digital signal processing techniques, then maximum frequency, then depends on the sample rate and nature of the converter. Then this one is nothing but the block diagram of the digital DSO. So just you need to provide the information of the control logic, then ADC. After that there is the DAC for the present the signal on the your CRT. We need to convert this signal from digital to analog. You need to provide the information related to that, and how there is the capacity of the storage capacity of the DSO, because it may be the different DSO is available in the lab, and those DSO is available in lab. There is the how much signals they have stored, because each have the different capacity and each have the different functions. So accordingly, you need to provide the information related with the DSO. This is the front panel for the DSO. This is the one slide. Those one is related with the signals, channel 1, channel 2, and analysis, how to measure the peak point and how to calculate the average signal by using this slide. These are the different interface as well as the function, those available in the DSO. These three operating modes are mostly important in the DSO. One is nothing but the roll mode, second is the store mode, and third one is nothing but the hold and save mode, because most of time I have observed in the second year there is the instrumentation. So these are the importance for the exam point of view as well as the understanding purpose of view. This is the video link. Then DC power supply. DC power supply is the basic thing, because we know the role of the DC power supply. Unregulated supply we have converted into the regulated supply, and for that which type of the components we have used, just give the information. First information related with the transformer, then give the information about the rectifier, because already students studied rectifier in the unit number 1. Then give the information related with the filter, and then at the last give the information about the regulator. In terms of the regulator, there are the different type of the regulator. It's possible it by using the simple Zener diode. It is also possible as the regulator. Give the example of the your charger. So suppose there is the any खराब झालेलं charger so just break this charger and find that there inside of that there it may be the Zener diode is available inside of that. So just give the information to the student, just handle the most of the electronics instrument or most of the electronics components. So it may be the related with the charger, it may be the related with the any type of the instrument, because all these things students already observe this thing in the ICO. There is the one DSO type instrument is available and there is the same function. So this is nothing but one of the example. This same example is given in your syllabus also. So you need to give this information to the students where we use the such type of the instrument other than our lab. नाहीतर स्टुडंटला असं वाटतं की हे फक्त लॅब मध्येच यूज केलं जातं, बट यू नीड टू गिव्ह द इन्फॉर्मेशन वेअर वी यूज दिस instrument outside in the industry or in the there are the different type of the application. It may be that you give the information related to the hospital, you may give the any one single example of the electronics industry. So this is the application of this function generator, this is the application of the DSO, this one is the application of the function generator or other instrument. Now this is the front panel of the power supply. This is the basic block diagram or related with their output waveform. Then function of the transformer, rectifier, and this thing. Okay. So now in this unit number 4, there are the total 4 instrument. These are the major instrument, and only we have the 6 lecture to cover this all part. So I just request to you, so just try to finish your op-amp in a 3 lecture and remaining 4 unit in a 3 lecture. Okay. So if we are observing the practical point of view, so there are the total 3 practicals are related with the unit number 4. So first practical is related with the measurement. So in our lab, so how to measure the AC signal by using the digital multimeter, by using the CRO, by using the DSO. So just try to keep this all multimeter as well as the CRO as well as the DSO. And there is the dimmer or rheostat is available in the lab. So just vary your AC signal and try to measure by using the multimeter. Try to measure by using the function generator. And if we are comparatively we measure this signal, so that time student definitely get the detailed information. This is the by using the digital multimeter. This is by using the function generator, by using the CRO, and this is by using the DSO. So try to give this information CRO and function generator for measurement of the AC or DC voltage. They just use the function generator, connect to the DMM also, and connect to the your CRO or DSO also, and observe the waveform and accordingly find out the value shown by the digital multimeter as well as the by using the CRO and DSO. Then how to measure the voltage resistance using the digital multimeter, how to handle this digital multimeter, then how to test the diode and BJT, because these all functions are already available in our digital multimeter. Then second practical related with this one is the rectifier circuit, implement of the DC regulated power supply using the bridge rectifier and diode. So just don't try to use the breadboard mostly to perform the practical, because there is no any exam. So try to perform this all practical by, suppose there is the ready-made kit, student only apply the signal, check the output. But if you are given the just provide the breadboard, 2 or 4 diodes for the full wave rectifier or bridge rectifier, then provide the capacitor, then provide the one Zener diode, then so you will get the regulated output. So and try to observe the waveform for the each point after the regulator, how which type of the waveform is available on the CRO, after the filter which type of the waveform is available on the CRO, and after the Zener diode which type of the waveform is available of the wave, and ask to them just draw the waveform with its value. So that time students will get the more information related with the all type of the blocks. Those are available in our power supply, including the rectifier, filter, and regulator. Then last application or last practical, that is the sixth practical, is the linear application of op-amp. So you need to use 741 to perform this practical. And again, I request to all, just try to, if you are the kit, no issue, but try to use the breadboard. So ask them to make the connection accordingly the circuit diagram and observe the waveform the inverting and non-inverting amplifier. So by using the function generator also, or by using the some digital value also. So how to calculate the gain, or how to design the any type design the value for the RF and RO or these things. So in a both way, first just give the values, ask them to design, find out the gain, then just give the gain and ask to them find out the value of the RF and RO. So try to discuss such type way the student should know the information about the design as well as the information related with the analysis. So these are the 3 practical related with the unit number 4. So these things I just given the information related with the how to conduct. I am not given the information related to the how to teach. So maintain the uniformity in the Savitri University in all colleges. Okay. So thank you. Suppose there is the any question or any queries in your mind, just we will discuss on that. Yes, anyone? Okay, thank you.
Thank you, sir, for your nice presentation. Now I will request Professor Lema sir to propose the vote of thanks for this session.
First of all, it is very good afternoon to all the respected faculty members who contributed in this roadmap program conducted from the KJ Institute of Technology and uh, organized with SCTA. Here, it's my great pleasure to express my immense pleasure to Dr. Ambade sir, JSPM's Professor and HOD ENTC, JSPM's JSCEO, Halapsar branch, to express his insight study about this topic, I mean subject, operational amplifier and electronics instrumentation. And sir has vast experience about this topic, and he has shared with us his comprehensive understanding of these subjects. Sir, really, I am very much thankful to you for your effort made to deliver this, informative session, and time is spent by you to prepare this informative session and express and guide us on this new roadmap of CPU 2024 patterns. Further, I extend my thanks to all the participants who contributed to make this program a grand success. Thank you, sir. Thank you, sir.
Let us move to the last presentation of this technical session. I will request Dr. Pratibha Chauhan, Trinity College of Engineering, Pune, to come on the dais. Welcome. I will request Professor Jyoti Sandhu Madam to introduce the resource person of the session, Dr. Chauhan Madam.
Thank you, sir. Good evening, everyone. It is my pleasure to introduce our esteemed speaker. Our expert for this session is Dr. Pratibha Pramod Chauhan, Dean Research and Development and Assistant Professor at ENTC Department at KJCOEMR Pune. Dr. Pratibha Chauhan holds a PhD in Electronics and Communication Engineering from Satyabhama University, Chennai, ME in Electronics Engineering from Pune University. Her area of interest is image processing, speech processing, signal processing. About professional societies, she is associated member of IT and life member of IST. With over 20 years of experience in teaching, she has also published more than 15 plus papers in international, national, conference and journals. Moreover, she has authored one book published by international publisher. Dr. Chauhan is regular reviewer of Web of Science Journal and IEEE conference. Moreover, 5 consultancies projects are carried out worth rupees 10 lakh. Please join me in giving warm welcome to Dr. Chauhan. With this brief introduction, I will request Dr. Chauhan ma'am to proceed for presentation. Thank you.
Thank you, Jyoti ma'am. Am I audible?
Yes, madam.
I know this is the last session and everyone is tired. Looking at your faces, I know this, and you are my teachers. So I understand the audience part. I quickly take a review of my presentation. Let's start with PPT. Outline of presentation. Start with the structures, guidelines, format, and implementation of CC. CC is the new concept. That's why I have mentioned in my presentation. The actual syllabus. So the question comes in mind in previous syllabus of basic electronics. Unit number 5 comes sensors and unit number 6 is communication system. So everyone, first question is only 2 hours given and 2 units club, and now the challenge is to teacher how to cover unit number 5 and 6, means the old syllabus, unit number 5 and 6. So don't worry, lot of parts reduced by the viewers members from the unit number 5 and unit number 6. Second important thing is little efforts reduced from teacher side, because in this unit you have to seminars, then quiz and the open book test, and the 6 marks given to this task. So at the start of syllabus, you prepare a group of students and distribute the work. So when syllabus come to the end, then everyone should ready with their presentation and this unit prepared by the students. This is scheme already explained by viewers members. So 2 hours only given to the theory and 2 hours practicals. Credit is 2 for the theory and 1 credit for the practical. I have said earlier, seminar presentation, then open book test and the quiz. These are the compulsory activity conducted, and for the credit is given 6 marks. Now, what is meaning of continuous assessment? Here, CCE, Comprehensive Continuous Evaluation Scheme they mention. So you have to do 30 marks for this. Means instead of in-sem examinations, CCE they have mentioned and 30 marks given to the CCE. Out of 30 marks, for each unit they have given 6 marks, and they mention the guidelines what to do in unit number 1, 2, then unit 3, 4. Particularly for unit number 5, they mentioned conduct seminar presentation, then open book test and the quiz. For the quiz, 2 options. One option is you can conduct quiz in your class. You prepare, make a groups into 5 and give the quiz. This is one method. Second method is when in the COVID session we conducted Google Classroom and Google Form. Likewise, you can also conduct the quiz. Then open book test. Student is open book test. It's very easy. But actually, whatever the tough contents, whatever the missing contents, whatever the latest technologies you want to cover, you can ask these type of questions from the open book test. So second advantage of open book test is student never give answer of what is the reference book or textbook for your syllabus. When you ask, even second year, third year, final year students, they are always giving answer. I am using Nirali. It's not bad book or good book. It's not question of bad or good, but students are able to give what is the book for your subject. So open book test compulsory conduct under unit number 5. And seminar presentation, not only presentation, they have to prepare 3 pages report. So thinking skill automatically start. That habit will be helpful for them in second year, third year. I am happy to share that my 45 students publish papers in KJCOEMR as well as Scopus Journal. From the second year, we started work on the students group, and that's why last year under internship we have conducted this activity, and 45 students of Trinity College published books in UGC Care as well as Scopus Journal, which is difficult task for teachers also, but they have done very easily. So that activity you also try for the first year student also. You can give the problem statement. They can write a review paper. That is also good activity. Why this is possible? Because the unit is sensor and communication system. So take one small example of sensor, like any sensor. You can take example and whatever is the application. Just take one example. Suppose solar system is there. In agriculture, we use the solar panels. So that kind of problem statement, if you are giving to your students, then they can design problem statement and they can write the paper. So that kind of activity you can ask your student. CO and course outcome. Here actual content of syllabus. As the unit is sensors and transducer, since everyone knows the definition of sensor and transducer, so just I have mentioned it. I will share my PPT with everyone. So what is actually sensor? Sensor and transducer, same concept. It converts physical quantity into electrical quantity. But when we say it is a sensor, when we say it is a transducer, example I have mentioned, when it is the piezoelectric crystal can be called sensor, whereas when it becomes transducer with appropriate electrodes in mechanism attached to it. So when you are using input, it becomes transducer, and in normal case it is sensor. So this is the difference. Many times students are not able to give correct answer of sensor and transducer. Then active sensor and the passive sensor. So this is the difference between active sensor and the passive sensor. In selection criteria, what are the selection criteria when you want to select the sensor? Obviously, your problem statement depending on that and the some parameters like cost, size, weight, types of output, interfacing, resolution, sensitivity, linearity, range, response time, frequency response, reliability, and the accuracy. In previous syllabus, lot of sensors they have mentioned as they cut down unit number 6, they merge into 5. That's why they reduce the sensor. It is possible to finish sensor and communication system within 6 archetypes. So they concentrate only on the sensors, start with the LVDT, linear variable differential transducer. Everyone knows when core is at the center, output is 0. When core is left, output is positive, right? Output is negative. Then only they ask two types of temperature sensors. One is thermocouple and the second is RTD. Only two temperature sensors are in the two syllables. The first is LVDT, second is thermocouple, third is RTD. Then obviously favorite question of examiner, strain gauge, to continue with the same. Then biosensor, fifth one. Okay, only 5 sensors. So it is difficult to cover 5 sensors. So only 5 sensors they have mentioned in the new syllabus. Then in the morning session, Dean Pramod Patil sir mentioned whatever the syllabus, even Patil sir also mentioned, whatever is your syllabus, you aware student how it is helpful for the industry. So this is the data acquisition system in which data is collected and it is given how you are getting output. So this is one example of data acquisition system. As we mentioned earlier, solar project. We have done 10 lakh rupees solar project. So this is one of the project done by my student. In this case, input is generated with the help of solar panels, as solar is free of cost. Once initial investment is large, but once you invest it, after that there is no electricity bill, and the output is useful for the irrigation system. So in this case, data acquisition system. Now, how IoT is used in this case? Farmers are at their home or somewhere offices. Nowadays, people are working in the offices and they are also developing their agriculture. So remotely they can monitor their agriculture system, farming system, and this is one of the projects done by my student. He is working in the industry and he is monitoring the agriculture. So whatever is the agriculture, he is monitoring from the remote side also. So with the IoT, it is really easy not to go to the agriculture place with the help of solar and IoT. This is possible. So with the example, you can also explain to your student. So sensor part is over. So only 5 sensors. One is LVDT, strain gauge, biosensor, thermocouple, and RTD. Only 5 sensors. Then in communication system, amplitude modulation, frequency modulation, everything they have skipped only communication system and GSM system, that is only there. And the media, wire and wireless, that's all. So start with the block diagram of communication system. I don't need to explain this. Input information is in the physical format. Maybe you type good morning message by text. You can wish by WhatsApp. You can call your friend and say good morning, or directly one to one you can wish good morning. The same way information is available in any term. Then transmitter transmit that information. Some channel is there. One is wire channel, coaxial cable, fiber optic cable, twisted pair. So with the help of channel, your information is transmitted. Whenever we say channel, noise is automatically introduced and receiver receives your information, decoding process is done. So same good morning message should be received and then decoding after that destination. Means that electrical quantity is again back to the original format. If you are sending text message, you receive text same message. If you are sending image, then you may receive the same good morning message in the image format. Then communication channel. First is the wire. Start with the twisted pair wire. In twisted pair, two wires are typically twisted and together in helix to reduce interference between the two conductors. Twisting decreases the crosstalk interference between adjacent pairs in a cable. Typically, number of pairs are bundled together into a cable by wrapping them in a tough protective sheet, low cost communication, and most of the offices in California twisted pair cables are used. Second is coaxial cable, as we know in PV cable, even Ethernet LAN cables we use the twisted pair. And third is optical fiber. Light is the source, and that's why the speed of optical fiber cable is high. Then, this is one more point from the last syllabus. Electromagnetic spectrum. Students should know electromagnetic spectrum because in the final year for their technical interview also the same question asked. The range of frequencies specifically they ask in their viva. So they should know the what are the different band of frequency. Very low frequency, medium, high frequency, very high, extreme high, super high. All frequency bands are here. They should know the exact application of particular band. Start with the extreme low frequency. Range is 30 to 300 hertz. Power line communication. Then voice frequency. Whenever we ask question to calculate sampling rate, that time student don't know the voice frequency. They always give answer 20 hertz to 20 kilohertz. So in the first year level, we should know the voice frequencies from 0 to 3 kilohertz. Then very low frequency, medium, high, and the applications are in front of you. Then next concept is cellular concept. High use of cellular network. So the same in the previous syllabus, continue with the cellular network. Everyone knows why the shape is hexagonal. So group of 7 they use and it is into the smaller areas called the cell and it become clusters. Same previous syllabus continue. Then the theory part is here. Shape of cell is hexagon. The reason already mentioned. GSM, Global System for Mobile Communications. So the block diagram always asks the question. SIM, subscriber, identity, modem, then mobile equipment, base station. Then BSC is the base station controller. HLR is the home location register. VLR is the visitor location register. And MSC is the mobile services switching center. EIR is the equipment identity register and the authentication center. So this is the block diagram of GSM Global System for Mobile Communication System. So mobile station, then base station and the network switching subsystem. So the same previous syllabus as it is continued. Same head part mentioned here. These are the reference books, sensors and transducer. I have taken notes from this book. First is the sensor and transducer, Patnavi second edition. Second is the Kennedy book and the mobile wireless communication expert book. And these are the reference. For you can contact to me. Okay. So any doubt in unit number 5? So any difficulty how to complete unit number 5 in 6 hours? So it's not very difficult task. 5 sensors, then block diagram, wireless transmission media. Only these are the part you have to mention. Important is with open book test and the seminar. You have to give the task to your student. To try this, you start from the first year only. Thank you. त्याच्यामध्ये किती होतं असेल?
Good afternoon, everyone. It's my privilege to extend our thanks to Dr. Chauhan Madam, Assistant Professor and RMD, KJEI, CCOER Pune, for her insightful session today on sensors and communication system. Dr. Chauhan has provided us with a comprehensive understanding of topics, sensors and communication system. So we deeply appreciate the time and efforts you invested in preparing and delivering this session in sensors and communication systems. Your expertise in sensors and communication systems has greatly enriched our knowledge. Once again, thank you, Dr. Chauhan ma'am, for your valuable contribution. We look forward to applying the insights you have shared and hope to have the pleasure of working with you again in the future. Please wait for validatory function. It's going to happen in within 5 minutes, 5 to 10 minutes.
सर कितना साउंड कसं हे करू का पिन काढून लावलं करायचं काय ते नाही म्हणत मी ते नाही दुसरं पुस्तक सेशन माझी
2 मिनिटाचा वेळ आहे तोपर्यंत मी थोडस याच्याबद्दल सांगते डेटा एक्विजिशन सिस्टीम बद्दल सांगते आपल्या actually it comes under unit number 5 data acquisition system. So what to do students in that case, they can take a small project like nowadays solar is electrical vehicle and the solar, these are the two challenges are in the market. So government subsidy, particularly for this EV project as well as solar project. So if anyone wish to complete project, then they can contact me. My number I have already shared. So for the 3 kilo, around 78,000 subsidy is given by the government. So if anyone is really, they can contact me. So our students are doing project under the solar. Last year we have given project to our students and they have done their work on the particularly solar and we got subsidy for each project around 78,000. So that is one good initiative by government. Second is I have reached presentation agriculture for agriculture right there. Actually, when we talk about solar, that kind initial investment is 3 lakh, 5 lakh rupees, that is in mind. But government gives 80% subsidy, only 20,000 we have to invest. The rest of things given by the government. Even at my hometown, we have received subsidy like 80,000. Hardly 25,000 we have invested and we got the Kusum Yojana. So that kind of project also your student can implement. Thank you.
It's a problem.
Good evening, respected dais, distinguished guests, and esteemed participants. It is with great pleasure that I welcome you all for the valedictory function of our faculty orientation workshop on basic electronics engineering of first year engineering. A special thank to our guest and resource person of the workshop. Your valuable insights and contributions have enriched our understanding and provided valuable perspective on how can enhance our curriculum to better prepare our students for the challenges of the future. I would like to request the participant to please share your experiences which you got in this workshop. If anyone is interested.
Anybody can come and share. So now policy.
Hello everyone. Myself, Assistant Professor Surekha Lumar from GS Mosey College of Engineering. I have previous experience around 4 years of teaching and 4 years experience in industry. So when I came back to Pavilion, because I am interested in teaching, talking and discussing the things, after that I realized that our teaching system is only on the basis of teaching. It's not skill. I'm very happy when I came back to the teaching system and the teaching pattern is 2024 is totally skill based and knowledge based, practical. So I'm very grateful that I have industry experience and I can implement with the help of teaching my that experience in with sharing with the students all those experience and I'm very thankful to all of this expertise who guided us how to teach our syllabus related to the industry and how to relate all those things, teaching and the practical knowledge, which is totally skill based. Thank you. Thank you everyone for listening to me.
If anyone wants to share the experience, please come on the dais.
So very good afternoon to respected principal sir, today sir, coordinator of the event and respective resource persons. So it's my great pleasure to express my understanding about this workshop and faculty orientation program on this basic electronics, because of this is one of the new roadmap of the SPPU, and the resource person gave his experience, share his experience to proceed. I mean, on the correct path on this new roadmap. So I am really thankful to all, and the workshop was really very informative for all of us. And I ensure to all the resource person and this person that whatever the effort taken, initial effort taken to mold the students, correct students on the correct path, and we will be able to satisfy their expectation.
Is anyone? Okay. I would like to request Dr. Suhas Koch sir, Principal KJ College of Engineering, to address the participants.
I think now it's concluding time, and you must have experienced all the technical informative digest in whole day. So I don't want to take much time for all of you. As a principal of this college and host of this particular faculty orientation program, it's my pleasure to host this particular program on behalf of Savitribai Phule Pune University. And I'm very much obliged that BOS CNTC and Dean Science and Technology has expressed faith in us and given us this opportunity to host this particular workshop, which was the first workshop under NEP for first year, and that was for basic electronics engineering. I'm sure that all the resource people, all the teachers, senior teachers, those who have given you the guidance regarding the theory as well as practicals for basic electronics engineering will be definitely helpful for you in your further teaching. But still, from university point of view, we are keeping this forum open, and any difficulties, any problems regarding this subject will be taken care, at least for this semester, from us. And any problem that you face, you can express your problem. Definitely we will try to solve it at university level too. As a teacher, you should always see that all the things are being properly bundled when you deliver your lectures to the students. And we should always see that maximum students should get benefit out of it. And I'm sure that up till now, the university results of this subject, that is basic electronics engineering, is always good. It doesn't mean that subject is easy. It means that all the teachers are hardworking, the teachers deliver their best, and the student accept their best. So the outcome of this subject is turned out to be very good at the university levels. So I once again thank all of you for all the delegates, those who have participated in this orientation program, all the teachers from various colleges under Pune University, and I once again thank BOS as well as Dean SPPU for giving us opportunity to host this particular orientation program. One more important thing is that during this tenure of one day, please give us sincere feedback. How was this particular day regarding the hospitality and all other things which are being provided, so that if there is any problem, we can solve it for the next time. Thank you. Thank you very much.
Share the material, resource material of this workshop within the week. As soon as the PPT, books, and the teaching methodologies arrive to resource person, we will compile it and we will share this material on the drive. The drive will be available for next semester, one semester. Okay.
We have now come to the one of the most anticipated part of our program, that is certificate distribution ceremony. To commence the distribution of certificates, I would like to request Dr. Suhas Kotsar, Principal KJ College, to distribute the certificate. So I will request Dr. Vasudha Patil ma'am, Shri Chhatrapati Shivaji Maharaj College of Engineering, to please take the certificate from the hand of Kotsar. I have madam. Professor Ajit Suryavanshi sir. Professor Vivekar Atul sir. Bharati Vidyapit College of Engineering. Professor Mahendra Shinde sir, PVP Ahmedabad. Shinde sir. Professor Sneha Kadam, College of Engineering and Research. Dr. Moses sir from PDS College of Engineering. Thank you, sir. I request Jopi sir for documents.
Remaining participants to collect their certificates from here only, because we have no time. The buses are waiting for.
Distinguished guests on the dais and esteemed participants, I am Dr. Gopi, here to propose vote of thanks of the valedictory function. I would like to extend my deepest gratitude to our esteemed chief guest and principal KJCOEMR, Dr. Suhas Koth, for gracing us with your presence and inspiring us with your insightful words. I would like to thank management of KJER, executive directors, Dr. Suhas Koth, principal KJCOEMR, for continuous support to make this event success. A special thanks to you, the organizing team of KJCOEMR of Faculty Orientation, Dr. Pramod Chauhan, convener and HUTNTC, Professor Vivek Ghanekar, Faculty Coordinator, and all the faculty of ENTC department. We appreciate the contribution of all the resource persons and participants who share their expertise and experiences. Let us acknowledge and appreciate the efforts of everyone who work behind the success to make this event successful, including the technical team, support staff, and volunteer. Your contribution are greatly appreciated. Thank you, sir.
फोटो लागेल तर आपण तिकडे बसू, तिथे बसूया, इकडून घ्या फोटो, तिथे जागेवरच बसा. बसूनच घ्या, बसा बसून. असं घेऊया, जर लागेल तुम्ही बसा, इकडून बसतो, इकडे बसतो. Okay, thank you. If you are versus our file components enough circuit select करा.
Professor Gitanjali is Sunita Deshmukh. Mimi. Professor Priyanka. Professor Surekha Dimani. Surekha Dimani. Professor Sandeep Negi. Neelam Srinivas.